So, hello everyone. Unfortunately, I cannot attend in person, but Francis is assisting me with Janna and Stefanie. Very pleased to be here with you to present the paper and the work we have undertaken with Stefanie Kunkel, Janna Axenbeck, and Francis Charpentier on comparing the ICT greenhouse gas emissions to the rest of the economy. Let me first, next slide, please. Let me first introduce you the core framework of the study. So we leverage an input-output model that enables the computation of comparable footprints between each sector of the economy. The scope of this footprint is limited to a cradle-to-gate modeling, and we focus on three main indicators for any sector or grouping of sectors of our data. Next slide, please. So let me present and introduce you the three main indicators we are bringing and talking about. So first, direct emission D of the sectors. For instance, obviously the energy sectors emits when burning coal. On the left, on the right, you can see the emission embodied in final demand noted F. That is all emissions that are all emissions generated all along the value chain to produce end user goods and services. It's typically a footprint that is a consumption based perspective. And in between, on the middle, we have the main concept we are bringing here and talking about. It's the emissions embodied in the total production of a sector, not a T. So it appears that the final demand indicators F does not account for all emission associated with the activity of a sector. A sector also produce goods and services for other sector of the economy to satisfy their own final demand need. So we are basically talking about here intermediate demand footprints. So if we aggregate this intermediate demand footprint with the final demand footprint F, it gives the total embodied emissions T of a sector. We also look at two associated indicators. T minus F, that is the emission caused by the upstream value chain of a sector, so all indirect emissions, and T minus F, that is the emission embodied in the intermediate demand of a sector from other sectors to the sectors. So now let me conclude this introduction by presenting you the data we use. So we investigate the time period from 2010 to 2021 using the FIGARO data set updated every year by Eurostat and the corresponding sectoral direct emission vector also provided by Eurostat. Next slide, please. So now digging into the results of this study, we first mean average all the sectoral results over the time period. And we end up by a three-dimensional plot. Next slide, please. Presenting the world scale sectors footprints. We include here 11 individual sectors of FIGARO and 5 grouping of sectors. ICT, as indicated in red, gathers hardware industry, noted computers, telecom services, and IT services. The total embodied footprint is given by the size of each bubble. As for ICT, its T footprints amounts to 2 gigatons of CO2 equivalent. Now trying to analyze the position of the ICT bubble on the X dimension. On the X axis, we see that 60% of the ICT footprints serve final demand. So only 40 remaining percent are emitted to satisfy the intermediate needs. And the most importantly, on the y-axis, we can see that nearly all the emissions, the footprint of the ICT aggregate stem from upstream value chain. So 95% of the total embodied footprint of ICT is indirect, and only 5 remaining percent are direct emissions. If we compare those performance directly to another sector like the energy one, which is the most emissive with 16 gigatons of CO2 equivalent, we see that the energy footprint is serving 70% of intermediate demand, and that contrary to ICT, and as expected, 90% of its footprint directly originates from its own emission, so it's direct emissions. So now breaking down this three-dimensional plot in two histograms, we know first rank the sectors with respect to their total embodied footprint in decreasing order. On the right histogram, you can see a split by destination of the T footprints between both final demand footprints and intermediate demand footprints. So final in blue and intermediate in red. On the left histogram, you can see a split by origin of the T footprints, whether it originates from direct emission in blue or indirect emission. By definition, if you sum up all blue bars on both histograms, it sums up to 100% of the GHG emission, excluding those from households that are not captured by this model. Now, if you look at full bars, it sums up to 230% of total GHG emissions, as it includes several double counting located in upstream value chain, so in scope 2 and scope 3 upstream. Now, using these typical histograms, we can compare the footprint importance on the left with the economic importance of the sector in the right. On the right, we plot the monetary production values of the sectors as a proxy of economic importance. We also plotted red and green dots that represents the total and direct carbon intensities of production respectively. We notice here two things. So first, ICT has a very different ranking in both histograms. So on the left, ICT is 13th in terms of embodied footprint, so as a low carbon importance, and on the right, ICT is 4th in terms of production values, so as a high economic importance. On the other side, we also can compare those figures with another sector, like energy, that is ranked first on the left and 9th on the right. So typically, these differences directly are related to carbon intensities. So as previously mentioned, indicated by dots on the right plots. If we now break down this ICT results into subsectors of ICT, so hardware, computer, telecom services, and IT services, we can see some insightful results. The first histogram on the left shows subsectors economic importance in monetary economic production. The second one shows total embodied T footprint and indicates notably proportionally higher contribution for hardware. The third one, as I said, with 95%, illustrates the direct emission that are negligible for all subsectors, including computer. The last histogram, finally, on the right shows the final demand footprint that represent roughly 60% of the total footprints with the same relative proportion as for T footprints. So now, having summarized the mean average results of this study, we can show you some trends and compare the total embodied footprint of sectors over the time period. To do that, we compute and compare the compound annual growth rates between sectors that are closely linked to sectoral economic growth, in addition, obviously, to decoupling. We do this for 2 time periods. First, a business as usual period from 2010 to 2019, as indicated by green bars, and for an extended time span until 2021 to look at the COVID effect as indicated by red dots. So we see that several sectors' footprint was not impacted much by COVID. For instance, IT services, construction, or the energy sector. On the contrary, and as expected, some sectors' footprints of impacted sectors have decreased. So it's the case for vehicle manufacturing, chemistry, and land transportation, and to a large extent in air and boat transportation, again, as expected. Some sectors, on the contrary, has boosted their footprint during COVID, so education, health, and government services. And there is only 3 sectors that exhibit a decreasing trend over the entire time span. So looking at business as usual period, it's finance, telecom, and education that exhibits a decreasing trend over the 2010 to 2019 time period. As for ICT now, let's focus on these aggregates and the main core of our study. So ICT footprint is increasing by 1% a year if we look at the aggregate sector. It's a slower rate than the rest of the economy at 1.3%. But the interesting results over there is that the trends for the 3 ICT subsectors are fairly different. So IT services growth rate is high, roughly 4% a year, and is top ranking this histogram. The second sector's hardware footprints evolved in the same trend than the entire economy, 1.3% a year. And finally, telecom services footprint is declining by 1% a year. Now having presented these results, let's discuss a bit results and overall the rest of the study. So first, we had to face some data consistency issues in the multi-regional input-output table we were using, so FIGARO. But what we can say is that those data are improving year by year and are exchanging between each other. So it's getting better, and but it still, as for now, requires some dedicated work to tackle some outliers and to analyze uncertainty to give some confidence intervals out of our results. To come back to the main results of the paper, we estimated the ICT footprints to 2 gigatons of CO2 equivalent, which is an extended assessment given that the FIGARO aggregates include non-ICT subsectors, strictly speaking. The share of non-ICT subsector in total aggregate is about half in terms of value added if we look at the OECD structural business statistics data. If we take this ratio and downsize accordingly, the RAF footprints gives 1 gigatons of CO2 equivalent, which now seems consistent with the reference studies. So it may be a perimeter issue. In the paper, we also investigate other comparisons including upstream footprint structure and cycling factors. Now to conclude this presentation, so input-output analysis provides a suitable framework and existing toolkit to compare ICT footprint to those of other sectors and to dig into value chain embodied emission. There is three main takeaway of this study in looking now closely at the ICT study subjects. First, ICT footprint is mainly indirect and located in the upstream value chain. That is 95% of the ICT footprint is located in the value chain. Second, annual growth rate of ICT is 1%. That is slightly below the average of the economy, 1.3% a year for the total economy. But however, subsectors footprint trends are really different. So telecom services activities footprints are declining by 1% a year, and IT services footprint is increasing swiftly by 4% a year. Thank you for your attention. And